Now that we have the general definition of sieves, we would like to use them to define a Grothendieck topology, and thus to define sites. But before we can do that, we need one more notion about sieves, and that's the so-called pullback sieve. So the purpose of this video will be to give that definition, and then in the next video we can get to the definition of a Grothendieck topology. So let's let C be a category, and let's let X to Y be an arrow of C. And let's let S be a sieve on Y. What we'd like to do is pull back that sieve on Y to a sieve on X. So we have something sitting on Y, and we'd like to move it back to something sitting on X. And there are two ways of doing this, or rather they're the same way, but there are two perspectives as usual, the internal and the external perspective. So let me give both. So in the internal perspective, S is a collection of arrows with codomain Y. It's a special set of arrows with codomain Y. So we define F star of S to be the set of all arrows with codomain X such that, maybe I'll say the set of all arrows G with codomain X such that f of G is inside of S. So what does this mean? Well, we have this map F going from X to Y, and we have some arrow, say G, going from A to X. And what we're going to do is say that G is in the pullback sieve. So we're going to say that G is inside of the pullback sieve F star of S if and only if f of G is inside of S. So if and only if this composition is inside of the sieve S on Y. So what the pullback sieve is the set of all arrows going into X such that if you follow that arrow by Y, you get something in the original sieve. Okay? So that's the internal perspective on the pullback sieve. And now let's talk about the external perspective. External. So in the external perspective, the pullback sieve will actually live up to its name. So we have this map, F, going from X into Y. By hypothesis, we have this map. This is sort of where we're starting. And now by Yoneda, this will give us a map from H of X, which I'm also going to call F, into H of Y. And now let's say that we have this sieve S sitting on H of Y. Well, we can actually form its pullback. In the category of pre-sheaves on X. Remember, this category of pre-sheaves is going to be complete and co-complete because the category of sets is complete and co-complete. Maybe I'll put up a video explaining why limits can be computed pointwise, because that's a useful general fact, and I suppose that's what I'm implicitly using here. But in any case, if you don't know that, just take my word for the fact that this pullback exists. And what we define the pullback sieve to be is, in fact, exactly this pullback. So it turns out that this pullback will be a sieve, and the pullback sieve is defined exactly to be this pullback. So we can just take this categorical pullback, and it's the thing that we want it to be. And that's what the external definition is of the pullback sieve. So of course, these two definitions are going to be equivalent. If you sort of use the equivalence between internal and external sieves, you'll see that these two definitions translate into each other.